morning. Thanks so much for joining me today. I'd like to motivate this work a little bit. My name is Eagon Meng, and together with Daniel Jackson, we're at the software design group at MIT. A lot of this work is about trying to understand how it is that we collaborate with both LLMs and people and to have a little bit of agency. And we're using some of these lessons to teach a course, the software design course. So I'd like to start by thinking about some of the motivations for a vision for software, not just for today, but also for tomorrow. One potentially contentious point is LLMs will continue to get better. I think this, depends on the degree, but a slightly less contentious point is our applications are going to grow a lot more complex. Now, the point here is that these are moving targets, that the need to collaborate in some shape or form will remain. And so what does it mean to work towards a structure for software that scales with advancement, no matter how much progress is made, no matter how complex things get? And so I'd like us today to think a little bit about the future of that collaboration and what are the properties that we'd like from that collaboration. So here are some of the goals that we've been thinking about for this shared vision. First being confidence. The idea here, the aspiration is contributing without fear, that you can make a change and it doesn't actually break anything. And the threats obviously being what we're very familiar with. The other goal is one that's a little bit more vague, but it's this idea of creativity, that you have the freedom to freely express new and interesting behaviors, that you're not sort of constrained by how tightly coupled things are. And the third is one of clarity. It's one that we should be able to ask the questions that interest us and find some sort of provenance to be able to trace it back to the source. So this talk is going to be about approaching these goals through a series of steps. And so working backwards, what properties of the software do we need to achieve this? Those are properties of the collaboration that we think are desirable. And our answer to that is this notion of legibility. And to achieve this, we'll introduce a structure that's made up of concepts and synchronizations, and we'll dive into that today. So the building blocks of software. We contend that there are these things called concepts. A very common way to structure applications these days might be something like an object, and in particular one that's very common might be a user object. So what might be some state associated with it? Now, for example, we have a name, maybe have some sort of email, perhaps a profile image or an avatar, some password, and some notion of logging in a session or a token. You might implement this in sort of an object-oriented way using a user class and associate all these different states with it and behaviors in terms of methods. And the question is this a good building block? Is this something that we think is a good foundation to rest the rest of our software on and to iterate on it over time? I would contend that there are multiple concerns here and multiple reasons to be concerned. For example, in terms of reusability, this is a rather specific combination of features. You can imagine applications that don't have some sort of login requirement, or others that don't have some sort of notion of a profile or an avatar. The other is breakage. Imagine that you're relying on some kind of database for your session management, it goes down, and now you can't access avatars from, let's say, your public site. And finally, it's this notion of evolution, where the requirements do change over time. And as you change each individual piece, how does that reflect on the rest of the software? Does it mean that you have to tread really carefully to make sure things don't break? So taking a step back and thinking about the etymology of concern, it's actually kind of fun. So you have the with or together, but I'm not sure how to pronounce this. Carnera, I believe. It's this notion of to sift, to perceive or comprehend, to discriminate or distinguish. And the idea behind a concern being to perceive an individual aspect from the whole. And I find that rather appealing. I think it's interesting to think about how we might extract a concern from a fairly conflated set of behaviors, such as this user class. Now, we might say that the first two states are part of some identifying concern. There are many ways to potentially uniquely identify an individual, and this is usually why these state requires a condition for uniqueness. But there might be more, maybe more than just name and email, maybe a phone number in certain applications. Then you might have a concern of some notion of a profile, not just the avatar, but some sort of biography or some other descriptive pieces of state. And then a notion of some sort of authentication. Could be passwords, could be passkeys, biometrics. And finally, any sort of notion of a session and logging in. So I would contend that these are the essence of the individual timelines, so to speak, of behavior that we do care about. And they're kind of grouped together and evolve on their own. So this is, in one way, a way to phrase what we think of as concept design. That concepts are these building blocks for software that embody concerns. They're described by a specification, and the first part of it being a purpose. This is the concern that you're addressing, the problem that you're solving, the reason for this concept that you've specified. Then there's the principle. This is a little bit like a canonical scenario, like a test case. It's how that concern typically plays out and why these behaviors, these informational updates actually satisfies the purpose that you laid out. Then you have the state, and this is a set of relations that pertain only to what you need for the concern, no more. And finally, actions, which are simply some behavior, a set of functions that update that state. And so one way to think about this is a concept is something like a state machine for a single concern. It describes its behavior over time, and it captures just the amount of state it needs to figure out what it needs to do. So an example, let's take our authenticating concept. Its purpose, ensuring that user matches what they claim in terms of identity. And a principle is fairly straightforward in this case. After registration, they can verify their identity by, let's say, a password. And you'll note that the state is simply just one line. It is one relation. The syntax here is modeled after Alloy. But the more important part is that we're just noting that it's a connection between user and some password string. By the way, the bracketed user at the top is our way of denoting some sort of generic import. You can think of this in practice as like a UID. We're not claiming anything about the actual type of the user or the structure of its information. We're just saying there's some generic thing that's called a user. And finally, the actions that you might expect, a registration and a check. And together, this authenticating concern kind of describes how a notion of password gets registered and how it changes over time and how we can check that it matches what people claim they are. One important point, and often a point of conflation, is that concept design is somewhat orthogonal to object-oriented programming. You can do both in each. So these are examples of just regular TypeScript objects and classes that are implementing concepts. And the key distinction here is that object orientation, in our view, is more about sort of the form, the structure. It's in the name. It's about objects and orientation around them. And while there are allusions to, let's say, entities in the real world that we can map sort of semantic notions on top of, it doesn't prescribe very strongly like what you should put in state and what kinds of actions should be related to methods. Whereas concept design is all about the function. It's about what is the purpose, right? We're telling you it's as part of the definition, you need to specify some semantic notion of importance and a principle and how it evolves over time. So there's some synergy here, and there's also orthogonality. So we've been here before. There's been many attempts at trying to structure more semantically relevant groupings for our software structures. Some like role-oriented programming, aspect-oriented. This might be seen a little reminiscent of entity component systems, heavily used in game engines and intensive 3D workflows. So what's new? One of the central contributions of the paper is thinking about this notion of putting things together. It might be okay to have some nicely oriented, separated concerns and classes. Maybe you did it well, but where's the challenge? So let's think about some patterns of composing these concerns. Suppose we consider each concept as some sort of microservice. It's just floating in the cloud, operating, you can stand them up on their own. And then the first pattern might be just let loose, allow all interdependencies. Right? I like to call this the hairball. It kind of looks like this. And I would contend this doesn't spark joy. If you look at this, my confidence is going down. I don't know if I can change one thing, if there's a race condition somewhere else. Creativity is way down. I don't want to add to this thing. There's a liability to maintain this. And I mean, clarity, just look at it. So another pattern that is common is this notion of, let's have some order. Let's route. Suppose we have some sort of client, it interfaces with an API gateway of sorts, and then we're going to let the gateway manage each individual concept, the microservice, independently. And we'll pray that the concepts don't actually talk to one another, or the microservices don't talk to one another. So this seems well organized. What might be some complications? Let's take a step back and think about a typical social media application. Imagine that a while the post appears, some new post has been created, and let's think about what happened right before it. What are some of the preconditions, right? Did we require a user to be logged in to create that post? What about the preceding actions? What led directly to that post? Beyond just they clicked a button on a page, it could be the case that, let's say for your site, uploading an image automatically generates a post. What happens after? So a post has been created. What are the behaviors that you want happen in your application? Well, first for the post condition, you want to post that, you want to persist that. And then succeeding actions, maybe something like we want all the followers of the poster to be notified. These are just some examples of perhaps desirable behaviors that you might want to configure and implement in your application. Let's take a look at how you might do this using that route pattern that we saw before. So this is just some notation from Node.js's Express server, but imagine you're setting up a route for a post request to post / some sort of user ID. And our first concern, again, thinking in terms of concerns and concepts, is, well, checking if they're logged in, some notion of a session. And if they are, we're going to do post.new. And then we want that kind of succeeding action, right? Get all the followers of this user who made a post. For each follower, let's notify them. All right, what if we wanted to have a different kind of pre-action or preceding action? What does that mean? So in the example of an image has been created, let's make an automatic post out of that. Well, we're going to have to start somewhere else, perhaps. There might be a different route for image uploads. The image is created, and then this is where we say, okay, let's make that automatic post after the image creation. Now, you might see the problem, which is we have all this logic that we want happen, right? We want all the posts to be automatically notify the followers. So we're going to have to repeat that. So we have following for each follower, notification. That might be okay for just 2 routes. And then let's say over time you say, hey, let's introduce some more behavior. Let's add recommendations. And for each post, we're going to have to update or re-index the recommendation algorithm. So we'll add that over here. And then don't forget, you're going to have to do that over here. This is a common pattern, and in many of the case studies that we looked through for the paper, we saw this replicated multiple times. And more importantly, what does it say about those desirable properties that we had, right? Is this confidence inspiring? Suppose your following microservice goes down, and now it seems to affect your ability to update your algorithm, even though it's orthogonal. What about creativity? We wanted to add this kind of unilateral function on top of new post creation, but we had to track down multiple places in which post creation was happening. And finally, clarity. Can you easily spot all those behaviors we're talking about, the preconditions, the preceding actions, all those, the before and afters of post new, from reading this code? So if we were to extract that, it might look a little bit like this. Here is the little bit about just normal authentication or through a session of some creation of a post. Here is that automatic creation of a post after an image. Now here is the concern about the whole following behavior. And this final bit is about the recommendation. And notice that it's actually just jumping across, right? It's really just dependent on the creation of the post to update algorithms. This is the essence of what we call synchronizations. What if we could just extract those and say, this is what we want to have happen? Here's what the syntax might look like. For the very basic one, the user post, suppose we consider the request coming in through that express handler as its own concept that encapsulates all the HTTP, all the other side effects, but basically says there's this action trace that request user post. So when that happens, let's check through the session that they're logged in, and let's make a post. This is how we declare behavior as a synchronization. And then the same thing for the image post. So when a new request for an image has been made and the image has been created, notice the 2 conditions inside the when clause here, then we create a post. And so to break that apart, what we're saying is that in this structure for synchronizations, the when keyword says, here are the preceding actions. Here are the triggers for this behavior that I want to occur. The where is, here are the preconditions on state. Here's the information that I think is relevant. And then the then is, here's all the succeeding actions that should happen. And that's it. Those are the only 3 keywords for synchronization. Importantly, note that we don't have this notion of explicit execution flow that kind of partitions the space into 2 route handlers. Both of these lead to one node, which is just post creation. What that means is for all that behavior that we said coming after, we can hook onto it. So the notify followers becomes a one-time declaration. When a post is created, find the followers of the user, notify them. Same thing for the recommendation update. And so in this way, by factoring out this kind of structure, we can kind of compose these concepts that are granular. They're declarative in the sense that they're not actually immediately calling them. They're saying this is what should be happening, right? And there's no duplication of that logic that we saw with that route, the route solution. So what does the implementation actually look like? It turns out to be quite simple. These 3 boxes on the top right, you can think of these each as like a concept microservice. They encapsulate whatever persistent store that you might use. A runtime, doesn't have to be node. And its main point of contact, they don't talk to one another, is through some intermediate engine, kind of like the mediator pattern from Kevin Sullivan, or just this notion of like an event-driven store. So they communicate action records as simple JSON structures. And then synchronizations are also data. They're just these patterns with the when, where, and then clause saved as JSON and then registered with the engine. And the engine itself is not a framework. It is just a library that can run in whatever deployment structure that you'd like. So what does a very basic concept look like? This is an engine that we did in TypeScript. It is any TypeScript class. All the methods are considered actions except for those with an underscore. So these are not recorded. And you have some sort of state. And the only requirement is that all your actions need to take in sort of a named record. So no positional arguments, just give it a record, a map of the key values that you want. And then a synchronization in TypeScript looks a little bit like this. So this is one that says, when a post has been deleted, find all the comments who have that target. So basically all the comments of that post, then delete all those comments. This is an invariant keeping synchronization to make sure you don't have any dangling comments. And you'll note that this returns just that data structure. It's a record with these when, where, and then keys. So let's talk about this notion of legibility that I talked about in the beginning, which is how do we understand the system that we're building up? Now, you can kind of think of these things as sort of these 2 layers. The concepts are these individual concerns. Here are some concerns that are fairly normal for social media apps, like notifying, friending. And here are some synchronizations about behaviors that you might expect it to be to have. And there's this property of integrity where there's no notion of some sort of horizontal flow of information between the concepts, right? Note that they don't know about one another, they can't import each other, and neither can the synchronizations. So they're always kind of in these vertical slices. Let's say you add a new concept. You say, okay, we have a recording concept, and every time a lecture has been recorded, we want it to post. This can be done in an incremental fashion. You don't have to think about integrating with an existing web of microservices, but rather you just simply need to add your concept anywhere and then say, here are some behaviors that you declare through synchronizations that you'd like it to compose with the rest of your system. And finally, the notion of transparency, which is what we were exploring with this idea of thinking about the before and the after of a post, that there's a specific place to look for preconditions on information, that's all in the where clause, and the preceding actions, which are all in the when clause. And because that's the only mechanism by which the system evolves, you have a guarantee that this is exactly where an invocation was called. Like if you want to look for how post.new happens, just search through all your synchronizations and see if it shows up in a then clause. We like to think of these 3 properties together as this notion of legible software, the ability to kind of read your software and understand it, to have a little bit of confidence about what's going on. And so we think these properties of the software lead to some of those properties that we talked about, our goals for collaboration. Now, namely, if you have this integrity, you might have a little bit more confidence that when you add pieces, it doesn't break the others by construction. Perhaps in terms of incrementality, if you feel like you can always just add one more thing, one more concept, one more synchronization, perhaps that leads to a little bit more creativity without restraint. You're not being hampered. And then this notion of transparency being a form of clarity, to be able to trace what is going on and ask questions that pertain to your system. There are, of course, drawbacks to any approach. We are very aggressive about this decoupling. So the decoupling of concepts, the positive is that they're fully independent. The negative is this thin straw in which they must talk to one another. There's no RPC, they don't know about types. It has to be some serializable JSON structure. The decoupling of synchronizations, it's nice that they don't have this property of context dependency. If you read through a route handler and you see post.new, it's actually pretty context dependent, right? You got to look up and see, okay, under what handler is this occurring from? How does this actually, what are the effects? Whereas synchronization will declare in the when and the where before that exactly what's going on. That said, that means duplicating all the conditions. So every time, it's not duplicating the logic, it's duplicating the context for every piece of action in the system. And who knows if that's a good thing or a bad thing. So this is a vision that we're thinking about in terms of evolving software together in a collaborative fashion, about concepts being a language for function. They're structured around individual concerns. They're in terms of these familiar shared terms of behavior, and that perhaps they can be constructed as a collective effort to evolve slowly, to be battle tested and shared amongst multiple applications, not have individuals redo the same user concept many, many times. At the same time, the synchronizations offer that kind of domain-specific configuration, the value that you want, the specific configuration of familiar concepts and the needs of your application. And we think this would be a targeted effort, that this evolves quickly. So a set of concepts like these with karma thread posting might create something like a Hacker News clone, which is something we've done before. So ultimately, taking a step back, what we're excited for, we're not actually super excited about kind of a new structure or implementation or even like a specific way of doing the software. We're more excited about this idea of this collaboration that can inspire confidence, creativity, clarity, right? That software will be legible to everyone it affects. And perhaps, maybe one day, that what you see is what it actually does. Thanks so much.
So we have plenty of time for questions.
I love the aim of the confidence, the legibility, all of us, I'm sure. You spoke about some case studies. Can you go a little, tell us a bit more? And in particular, in those case studies, have you compared with the competition, for instance, with aspect-oriented programming or earlier approaches also developed at MIT?
That's a really good question, thank you. So in the paper, we mostly explored this, there's a picture of it, something called the RealWorld benchmark. This is actually a pretty fun benchmark if you've heard of it. It's purporting to be the mother of all demo apps. It's kind of like a Medium clone, like a social media app with a lot of blog posts. And the interesting thing is this was kind of like a developer organized effort. So there are hundreds of implementations across many different languages, a lot of esoteric ones as well, all implementing the same app. So what we did was we also implemented our own version. We did some not comprehensive, but basic studies on sort of like an industry perspective. So no, unfortunately, we didn't have sort of strong comparisons against like aspect-oriented programming and perhaps more of the other higher level approaches, but we mainly focused our efforts on comparing on, well, how do people do it in software practice today and looking at those details.
Thanks for your talk, Jonathan Aldridge from Carnegie Mellon. I've been a longtime fan of concepts, so it's great to see that you're working on, you know, how you can make them a part of building software. So I really enjoyed your talk. I think the first sort of concern that comes to my mind about this is the synchronization part, and I wonder about scalability, right? Because synchronization is about the interaction, which is always the hard part in software, and especially when you think about concerns, right? this was a challenge in aspect-oriented programming too. You separate the concerns, but how do they integrate? And so I wonder, as you add more concerns, does the synchronization between them kind of, does it turn into a quadratic kind of thing, right? Where each concern needs more constraints in the sync part, in the sync that that accounts for it to mediate between others. It's an empirical question, perhaps, but I wonder if you have any insight about this issue.
That's a wonderful question. Thank you so much. That is essentially the primary goal of this entire research project. We had an interesting notion of concepts, but we've always struggled with how to actually compose them. Previous versions of a class were done on top of this routing pattern, and it had all these problems of it didn't scale, right? We had to track down, okay, all these concepts, the concerns are everywhere, how do we actually merge them? And so this is experimental. It seems hopeful, but there's a lot more details I was not able to get to during the talk about some notions we developed of an execution flow, about a notion of how to group actions. It turns out that it's very powerful and distinguishes this from a traditional event-driven system and reactive system because we have a notion of what it means to have multiple conditions in the preceding actions. It may seem strange, like if you condition on like a request and like a user signing in, well, there are thousands of users doing both at the same time. How do you group that? And our particular notion of a flow that groups that seems to cut through these concerns pretty well. Obviously, there's so much more to do and think about other cases, but it seems pretty hopeful that we've found essentially a language. That's why we centered around these three keywords of trying to be like, if we can describe that behavior, we should be able to put it in just that much text.
Yeah, thanks for the cool talk. I was wondering if you could talk a bit more about the class. So like, are the students using, how many students do you have? What level? Are they using your language? And also I'm curious, like, are they doing one project through the whole quarter? How are you guys, how's this class working?
Yeah, the class is going right now, and it's a source of a lot of fun and stress. But essentially they are going to be using this pattern, and they're starting to integrate it already. The class is really structured into two projects, a personal project and kind of like a group project, and we'll see how they do on sort of both. We're interested in the ideas of actually having reuse of concepts between multiple people, see how that pans out. But we're also doing all sorts of other things in the class, like welcoming students using LLMs. And, yeah, it's an ongoing story, and we'll have much more to report on next spring.
Cool, thanks so much.
Any further questions? Okay, then I should thank the speaker.
Thank you so much.